All right, today we are diving deep into the blueprints of our reality. And no, I'm not talking about the ones on paper. I'm talking about the invisible ones we build inside our own heads. I mean, really think about that for a second. How do you get through your day? Every single thing you do, from the simplest little task to the biggest, most complicated decision, how do you do it? How do you just know what to expect or what to say next?
Well, it turns out you're constantly looking at a set of invisible blueprints. Yep, these are your brain's internal maps for how everything works. You know, from making a cup of coffee to trying to figure out what someone's really thinking. Today, we're going to break down these blueprints, which scientists call mental models.
So here's our game plan. First up, we'll figure out what these models actually are. Then we'll look at how we use them every single day, and of course, what happens when they go wrong. We'll also get into how our brains are smart enough to update them. And finally, we'll tie it all into the wild world of artificial intelligence.
Okay, let's lay the foundation. What in the world are these mental blueprints we keep talking about?
So this idea isn't exactly new. Way back in 1943, a psychologist named Kenneth Craik came up with this idea that our minds create these small-scale models of reality. But here's the key thing, the part that's so important. They aren't just still pictures in our head, no way. We are actively using them to reason, to explain why things happened, and maybe most importantly, to predict what's going to happen next.
Just think about making coffee. You don't consciously walk yourself through every single step, right? Step 1, get mug. Of course not. That's because you've got this deeply wired mental model, a sort of procedural blueprint, just running on autopilot. It's the perfect example of one of these internal maps guiding your actions without you even having to think about it.
But, our models get way more complicated than just a simple recipe. Research actually points to something called a dual theory for how we handle concepts. So on one hand, you've got the core description. That's kind of like the dictionary definition. For a bird, it's a warm-blooded vertebrate, has feathers, the whole deal. But then on the other hand, you have the identification procedure. And that's how you actually spot a bird in the wild. It's your mental picture of a typical bird, like a robin or a sparrow, that lets you see one and instantly go, hey, a bird, without having to run through a biological checklist. Both of these parts are absolutely crucial to the same mental model.
All right, so we know what they are. Now, how do we actually use them? Let's see how they scale up from something simple like making coffee to, life's biggest decisions. And this whole process isn't just some random, messy thing in our heads. When we're making a really complex decision, we're using our mental models in a surprisingly structured way. As this research shows, we first build up arguments for our beliefs and options. It's only after we've done that we start comparing them. So our final choice is literally built on the foundation of these internal blueprints. And you see these things everywhere. I mean, we use them for formal logic problems. In finance, you've got investors using mental accounts to sort their investments. That's a super clear mental model that can totally override pure logic sometimes. A programmer trying to fix a bug, they have to build a mental model of another programmer's code just to figure out what's going on. And anytime we work together, like on a team, we're relying on a shared mental model of the goal and who's supposed to do what.
But here's the catch, right? Our internal blueprints are not perfect copies of reality. Not even close. They're more like sketches, and sometimes those sketches have some pretty serious flaws.
Yeah, as the research makes very clear, our blueprints are built with limited reasoning. We don't have endless time or brain power, so we take shortcuts. And look, these shortcuts are usually super efficient, but they can also lead to some systematic errors and what are called false beliefs. Basically, cracks in our foundation and our understanding of the world.
Let's look at a couple of classic examples. First, you've got cognitive dissonance. Our mental model wants to believe that our actions and our beliefs are perfectly in sync, but in reality, they clash all the time, and that causes real mental stress. Or how about the endowment effect? This is where our mental model tells us that the mug we own is somehow more valuable just because it's ours. We totally ignore the fact that an identical mug in the store costs the exact same amount. In both cases, you've got a direct collision between our internal blueprint and the real world.
And honestly, the list of these failures just goes on and on. Ever heard of the curse of knowledge? That's when your own expert blueprint of a subject makes it practically impossible for you to explain it to a beginner. Or there's the logical omniscience problem, which points out a really fundamental limit. Nobody, not a person, not an AI, can possibly know all the logical consequences of everything they believe. So yeah, our blueprints, they are far from perfect.
Okay, so if our models are so flawed, are we just stuck with them forever? Well, no, not at all.
And this is where it gets really incredible. The most amazing thing about our brain isn't just that it builds these blueprints, but that it is constantly revising them. And here's the really mind-bending part. Learning isn't just a one-level thing. Our brains don't just strengthen the connections inside a model. No, they operate at a higher level. They can actually change the rules for how those connections get made in the first place. Essentially, our brain is learning how to learn. The fancy scientific term for this is meta-plasticity, or the plasticity of plasticity. Think about it like this. If regular learning is like writing on a whiteboard, meta-plasticity is like changing the type of marker you're using or even the eraser. It's this fundamental biological process that lets our brain learn how to learn, which makes our mental models way more flexible and able to adapt to new information.
And this is exactly how we go from being a total novice to an expert at something. You start out with a really simple and probably pretty inaccurate model. Then, with practice, those connections get refined. And eventually, that rough sketch turns into an expert's detailed blueprint, a super complex and highly predictive model for navigating that part of the world.
But here's the thing, we don't always need direct, hands-on experience to update our models. We can also do it by just running simulations in our heads. This is called counterfactual thinking. It's that what-if game we all play. By imagining different outcomes, we can actually revise our blueprints without having to suffer the real-world consequences. It's an incredibly powerful and efficient way to learn.
And that brings us to our final piece of the puzzle, where we connect the human brain to the digital minds we're building right now.
You know, for the longest time, the main focus in AI was just about feeding it more and more and more data. But we're starting to realize that real intelligence, the kind that can reason and predict and explain itself, it needs more than that. It needs the AI to have a solid internal model of the world, a blueprint it can use to actually make sense of all that data. And this is where things get really interesting. There's this whole field called explainable AI that's trying to crack this exact problem. Like, what makes a good explanation from an AI? Well, according to this idea of model reconciliation, a good explanation is when the AI can show you how its internal model led to a decision in a way that lines up with our mental model. It's all about finding that shared blueprint so that we can actually understand its thinking.
And it turns out, AI is running into a lot of the same roadblocks we do. Just like us, it struggles with that logical omniscience problem, and it has to figure out how to reason with limited resources. It's got to learn how to avoid forming false beliefs, and maybe the biggest mountain to climb is developing a theory of mind, which is the ability to create a mental model of our mental models. Wild, right? So that leaves us with this final big question. We've seen how our internal blueprints don't just reflect our reality, in a lot of ways they actually create our experience of it. So, as we get closer and closer to building artificial intelligence with its own complex, adaptive mental models, we have to ask ourselves, what kind of reality is it going to build? And how is that reality going to line up with our own? That's a blueprint we are all, right now, designing together.